Hello, this lesson is on the second fundamental theorem of calculus. This lesson sounds more intimidating than the actual title, and I think you'd welcome or understand once we do this that it's not as difficult as it sounds. So the second fundamental theorem of calculus, if I could zoom in here, I know that you guys don't have the notes. You could take notes or you could just listen, it doesn't matter, but I want you to understand how this works. What the second fundamental theorem of calculus says is if you have, as we've done before, the fundamental theorem, first of all, let's review real quick. The first fundamental theorem of calculus, we said that the derivative of a derivative of the antiderivative. Oh, sorry. Just kidding. We said that if I took the antiderivative from a to b of the derivative, right? This is the first fundamental theorem of calculus. If I take the antiderivative of the derivative, that is the same thing as the function of b and the function of with a and subtracting the two. So that's what we did a whole bunch of practice examples on, the first fundamental theorem of calculus. And we did it with a graph, we did it with a function, we did it with a lot of different things. Now, the second fundamental theorem of calculus is kind of like the reverse. So the first fundamental theorem of calculus is taking the antiderivative of the derivative. The second fundamental theorem of calculus says, what if I take the derivative of the antiderivative? Okay, so if I zoom in here, you can see that you see a letter C here that stands for a constant. If you take the derivative of the antiderivative, so if you take the derivative of the antiderivative of some constant to some value, some function x, and you notice if it's some function with t, so you see that these variables don't match up, is the same thing as just plugging in x for the function. Okay, and it sounds confusing, but again, as usual, as we do some of these examples, it'll make a little bit more sense. So if we look at the first example here, it says all of these we're trying to find the derivative of the antiderivative. So it says here find the derivative, and I'm trying to find the derivative of the antiderivative. Okay, so if I'm trying to find the derivative, it looks something like this: d dx of negative 1x t to the 3 minus t dt. So if I'm taking the derivative of the antiderivative, okay, all you do is you take that new variable. Also, I'm taking the derivative of the antiderivative, and I have a constant. So that's the one thing that you're checking. You have a constant on the bottom. All you do is take your new variable, in this case is x, and plug it in. So the answer, again, this is much easier than it sounds, is x to the third minus x. So if you're taking the derivative of the antiderivative, all you do, and you have a constant on the bottom, is take the new variable and plug it into where the old variable is. That simple. Okay, number two. This one is a little bit different. I'm still taking derivative of the antiderivative. Okay? But you'll notice something different that we didn't see in the last problem. In this problem, I don't have a constant on the bottom. In this case, I have my constant on top and my variable on the bottom. So what you do is, one of the rules of antiderivatives is that you could flip the bounds, but you have to make it negative. So I'm going to call this negative d dx, the derivative, of pi over 3 to x of cosine to the fifth t dt. So now all you do, again, is take my new variable and plug it into where I see t. So the derivative, remember I still have a negative out in front, or my answer is negative cosine of x to the fifth power. Again, it's that simple. All you have to do is take the new variable and plug it into where the old variable is. So you're saying like, oh, how does it get more difficult? Because you always make the questions a little bit more difficult. Well, how about this one? Okay, this one I have my constant, that's good. But this one I don't have an x, I have a 2x. Okay, how does that change the problem? Let me show you. So if I take the derivative of the antiderivative, again, all I'm going to do is take my new variable and plug it into where I see my old variable. So all I do is plug in 2x everywhere I saw t. Now, remember when you take a derivative and there's a function inside a function? So that was called the chain rule. So in this particular problem, I have a 2x inside of a function. I'm taking the derivative of it. So after you take the derivative of the antiderivative, not only do you have to plug in the new variable, but you also have to take the derivative, multiply by the derivative of the inside. So in this case, I plugged in 2x. I think you all see this. I've plugged in 2x, but I have to multiply by the derivative of the inside. And the derivative of the inside for this particular problem is 2. So the answer to this particular problem is going to be 2 sine, again, I have to 2x to the third power. So 2 to the third power is 8, and then x to the third. That's how you do it if you don't have a just plain x as one of the bounds. Okay, number 2. So I'll try to mix it up a little bit for you guys. Here, same thing, derivative of the antiderivative. I don't have a constant. It's on the top. I don't have a constant on the bottom. Okay, so what I'll do first is I'll make this negative, and I will flip it. Oops. And I will flip it like so. Hopefully you're okay so far. So all I did was flip it, make it negative. Now, everywhere I plug in, or everywhere I see the old variable, I'm going to put the new variable. So my answer is going to be the cube root of 8x squared plus x squared to the 4th power. Again, everywhere I see t, I'll plug in x squared. And then I multiply by the derivative of the inside. My inside function is x squared, so I'm going to multiply by 2x. So my answer is going to be 2x, the cube root of 8x squared, and then x squared to the 4th power is x to the 8th. And that's my answer. And that is all the sample problems I have for you. Again, it's a very, I don't want to say it's a difficult topic, very hard conceptually. Most people don't understand why am I doing this, and I choose not to explain it so in detail. I think you just need to understand the process. You take the derivative, the antiderivative, just plug in the new variable. If that new variable tends to be a function, then multiply by the derivative of it. So hopefully it's very simple to understand. If you have any questions, just let me know, and I'll see y'all later. Take care.